All right, today we're going to be talking about exponents. Now, what is an exponent? And usually when we're talking about exponents, we're referring to when we have a base, let's say, for example, x, and raised to a power or index, or typically called an exponent. So let's say we're talking about x to the power of 4. Okay, so again, x referred to as our base, and this 4 we can call the exponent commonly, or you might also see index or power. Okay, all these are just different words that mean the same thing. Now, x to the power 4, what this means is that this is the same as x times itself 4 times. So x times x times x times x. And that is a quick definition of what is an exponent. So sometimes we may be asked to expand or simplify an exponent. So for example, we might see something like 2 to the power of 5. Okay, so if you want to expand this, again, just using our understanding of exponents, we have 2 as our base, okay? 2 is our base, 5 is our exponent, which means we're going to multiply 2 by itself 5 times. So 2 times 2 times 2 times 2 times 2. Okay? You may be able to work this out in your head or with a calculator. We get 2 times 2 is 4, times 2 again is 8, times 2 again is 16, times 2 again, and we get the simplified answer, 32. Now, there are a few special rules that can be applied to exponents which help us simplify expressions. The first we're going to introduce today is called the product rule. Okay, so whenever we're multiplying exponents or powers that have the same base, meaning in this example we have here, the base is x. Okay, if this is not the same base, this rule does not apply. But since this is the same base, we have x to the power a times x to the power b. The product rule states that this equals x to the power a plus b. Okay, so this may make a little bit more sense if we can see it in action. So again, let's stick with x. If we have x to the power of 3 times x to the power of 5, and we were asked to simplify this, we'd again first recognize that the base is x in both of these, so we can apply the product rule, and we get x to the power of 3 plus 5, okay, which we know would simplify the x to the power of 8. Quotient rule, okay, so much like the product rule, these have to be the same base. This example here, our base is x again, and if we're dividing, so here we have x to the power a divided by x to the power b. If we're asked to simplify this, this would be equal to x to the a minus b. Again, if you want to look at an example, we could have something like 2 to the power 6. We're dividing by 2 to the power 3. Okay, we could work this out in our calculator and get a number, but we know that this is the same base of 2. So this is equal to 2 to the power 6 minus 3, which is 2 to the power 3. Okay, that's 2 times itself 3 times, 2 times 2 times 2, which simplifies the value of 8. Okay, next we're going to look at any base raised to the power of 0. Now, this might be the toughest to comprehend, but it's actually the most straightforward rule, because anything raised to the power of 0 is 1. Okay, whether it be 2 to the power 0, 5 to the power 0, 10,000 to the power 0, or just the general term x to the power 0. We're always going to end up with the value of 1. Okay. Now you might just want to memorize that and accept that, but if you want actually some proof of why this is true, we can look at a quick example using, we can say either our quotient rule or power rule, and for this one I'm going to use, let's say, the quotient rule. So let's say I have x to the power, let's use a general term, let's call it a, and we're dividing this by x to the power a. That's ugly x. Let me redo that one. So we have x to the power a divided by x to the power a. Now, we know everything dividing by itself equals 1. Whether it's 3 divided by 3, 10 divided by 10, we know this expression equals 1. Okay? But we also know that x to the power a divided by x to the power a using our quotient rule is x to the a minus a. Okay, that's just our quotient rule. Same base, we subtract our exponents, and we know any number subtracting itself is 0. So x to the power 0 equals 1. Okay, so by applying our quotient rule, we were able to prove that any term to the power 0 does in fact equal 1. Okay, and the last rule we're going to look at on this video is how to deal with negative exponents. Now you might ask yourself, well, what's the problem with a negative exponent? And realistically, there's not a problem. If we have something such as x to the power negative a, there's not necessarily anything wrong, but in math, there's usually an acceptable way to write things, and typically we don't want things expressed with negative exponents. Okay, but the good side of that is it's very easy to get rid of a negative exponent, because all you do is you move it to the other side of the fraction sign. Okay, you might say, well, where's the fraction? X to the power negative a. But we know any number that's not expressed as a fraction is just over the value of 1. Okay, so if we want to get rid of this fraction, all we do is flip that fraction around and make that exponent positive. So what we end up getting is the 1 moves to the top, the x to the negative a moves to the bottom, but you get rid of the negative, make it positive, and get x to the power of positive a. Okay, so looking at another example, if we had 2 to the power of negative 3, we would flip our fraction. Okay, we don't really see a fraction here, but it's 2 over 1, so we make it 1 over 2. Okay, your exponent goes with the base, and we make it positive. So we get 1 over 2 cubed, which is 1 over 2 times 2 times 2, or 1 over 8. Okay, so now it's expressed without a negative exponent. It's acceptable as a good mathematical format, and that would be our nice, clean final answer.